Hey guys, sorry that I'm not in school today. Still feeling a little sick, but I wanted to give you some examples so that you could understand what we're doing today. Today we're solving a systems of equations by graphing. So let's just go ahead and dive into what that looks like. First of all, we need to remember what our x and y intercepts. Remember, our y-intercept is when we cross our y-axis. Our line crosses our y-axis, and our x-intercept is when we cross the x-axis. How we graph using these is we either plug in 0 for x or y, and then we find our x and y intercepts, and then we graph the line between them. So if I find the x-intercept at -2, 0, that would be right here. And if I found it to be positive 0, positive 2, it would be right here, and then we could graph a line by connecting those two dots. Today we're going to be talking about how we can use graphing to find the solution to a system of equations. This intro problem starts off with a campground offers tubing, kayak, and bicycle rentals as shown. Write an equation to represent the total cost y of renting a tube for any number of hours, x. So you see the equation written there, but let's pretend that they didn't give it to us yet. Well, we know that the deposit that we're going to have to spend anyway is 15, so that is a constant amount we're always going to have to spend no matter what. Plus, well, how much do they charge us per hour? Per hour, it's $4.20 per every hour. And that's going to equal whatever our y is, or whatever our total cost is. So we can do this for all of these. For a kayak, it would be 25 plus $6.50 for every hour is equal to y. For our bicycle, it'd be $20 plus $7.50 an hour is equal to y. And then we could calculate for how many hours in different situations. But this is how we can represent multiple systems with the same kind of equations. So one or more equations with the same set of variables are called a system of equations. So y equals 4x and y equals 4x plus 2 are a system of equations. Basically, this just means we have two or more lines together on the same graph. We can estimate the solution of a system of equations by graphing. So let's go ahead and look at what we have here. So it gives me a system of equations, system of equations. It gives me y is equal to -2x minus 3, and it gives me y is equal to a 2x plus 5. And we need to solve this by graphing. How we solve this by graphing is we just simply graph those two lines and we find where they intersect. So if I graph -2x minus 3, I know I'm going to start at 0, -3, because that's my y-intercept. So there's 1 point. And I can find my next point by going down 2 to the right 1, or going up 2 and to the left 1. That is just graphing that we have already covered and we've already done. So then I can go ahead and graph this with my ruler. So, and it's important to graph your line all the way across because we're not sure where these two lines are going to intersect. So then I'll go ahead and graph our next line. I'm going to start at that plus 5 because that's our y-intercept. So 1, 2, 3, 4, 5, all the way up top here. And then I'll go down 2 to the left 1, or you can go up 2 to the right 1, which would probably be about right there. And we can again graph our line. So let me move my ruler over. Oops. So that we can graph this line. And it looks like when I finally graph this line, it looks like our point is pretty close to intersecting at this point right here. Since my graphing isn't perfect, I'll probably get pretty close, but it might not be exactly on the point. But I think the solution to this systems of equations is going to be that -2, +1. Let's double check we were right. It appears to intersect at -2, 1. This estimate is replacing with x with -2 and y with +1. So you can double check this by plugging in these points to these systems of equations, and they should be equal. So if I plug in 1 for my y, I should get -2, well, x is -2, -3, so that's that first equation there. This should be a true statement then. Well, -2 times -2 is +4. -3 is equal to 1. Is 1 equal to 1? It is. And then you could also plug it into the second system. If I do -2 times a +2, I get -4. Is -4 plus 5 equal to that +1 we plug in for our y? It is. So we know our answer is correct. Alright guys, so let's go ahead and look at an example where they haven't given us those two equations to already graph. How do you find an equation to graph? So Gregory's Motorsports has motorcycles with 2 wheels and ATVs with 4 wheels. So the store has a total of 45 vehicles that altogether have 130 wheels. So I'm going to go ahead and make y equal to our number of motorcycles. This pen's a little thick. Let's make that a little thinner. X, let's go ahead and make equal to our number of ATVs. So what we already know is that if I take the total number of total number of ATVs and add it to the total number of motorcycles, altogether I'll have 45 vehicles. What I also know is that a motorcycle has 2 wheels, so 2y, and an ATV has 4 wheels, so 4x. And if I add up all the number of wheels, I get 130. So how do I graph these? Well, we're going to have to turn these into slope-intercept form. So if x plus y is equal to 45. Well, if I have x plus a y is equal to 45, I need to get y all by itself. So subtract x from both sides, and I'll get y is equal to a negative x plus 45. The second one's slightly more difficult. We have a 4x plus a 2y is equal to 130. So I will subtract 4x from both sides to get that 2y by itself. And I get negative 4x plus 130. So now to get that y all by itself, I need to divide both sides by 2. So divide everything on this side by 2. And I get y is equal to a negative 2x plus 65. So now that we have those two equations, I can go ahead and graph that on a coordinate plane. I'm going to go ahead and write my equations a little bigger up here. I have y is equal to a negative x plus 45. And I have y is equal to a negative 2x plus 65. So I'm going to go ahead and count by 5s here. So I'll have 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. That's probably not enough for this 65. So let's go ahead and count by 10s. So 10, 20, 30, 40, 50, 60, 65. Okay, so that'll match. So if I count by 10s here, 10, 20, 30, 40, 50. I'm going to be in between that 40 and 50 for my first point. I can zoom in a little bit here. And then I need to go down 1 over 1. So if I go down 1 over 1, it's probably be right there. Graph my line. It's going to look something like this. Actually, so now that you have those two equations, all you need to do is graph them. And when you graph them, you get something like this, which gives us our answer of 2025. I'm just going to, so that you don't have to watch the painstaking effort of me graphing those. So let's go ahead and look at this next problem I have for us. Creative Crafts gives us scrapbooking lessons at 15 an hour. So sorry, we have 2025. And that means this point intersects at the point that he has. He has 20 ATVs and 25 motorcycles. That's the point where both of them have the equal number of wheels just make sure you can interpret that number of solution, because in this one we have to interpret our solution. So let's look at this. Creative Crafts gives scrapbooking lessons for $15 an hour plus a $10 supply charge. So we know the total cost is going to be our y, because that's on our y-axis here. So I'll have y is equal to, well, how much are they charging us per hour? $15. So $15 per hour x, because hours is on our x, plus that $10 supply charge that we're going to get charged no matter how many hours we do scrapbooking. Scrapbook Incorporated gives us lessons for $20 an hour with no surcharge. So we have y is equal to just a $20 per hour plus nothing, because they don't charge us anything additional. So then we'll go ahead and graph these equations. So this one I'll have to start at plus 10. That is my first point. Then I'll have to go up by 15, which would put me at 25, go over 1, up 25, over 1, up 25 from 25 would be 40, over 1 would put me at 40 and 2, or 2 and 40, I guess. And then I'm going to go ahead and graph this line. Sorry, my ruler takes a while to scroll to get it to the right angle that I need. Ooh, voice crack there. All right, so we got our points. Graph that line. It's a beautiful line. It's not exact, but it'll do. When we don't have a y-intercept, we're going to start at 0, 0. That's our first point. And then I'll go up by 20 over 1, up by 20 over 1. And it looks like this point is where they're going to intersect. When I graph this line, it looks like when I graph these lines, they intersect at that point that we just got at 240. So now I need to interpret what that 240 means. Well, that 240 stands for our total cost is going to be 40 for both of these at 2 hours. So I would say at 2 hours, because that's our x, and then y is our total cost. Both, and you could even say Creative Crafts and Scrapbooks Incorporated cost $40. That's what that solution to the system means. We found where they are equivalent. Now there's one other thing I kind of want to go over with, and I just kind of want to present this in PowerPoint format for you guys. So there's 3 different situations we can have with our different number of solutions. Number 1, we can graph a system of equations that indicates, when we're graphing a system of equations that indicates a number of solutions, if they intersect at one point, then there's one solution. If our lines are parallel, they are never going to cross. That means we have no solution. And if we graph the same line, then there are infinite number of solutions. So for something like this, where I see we have the same slope but different y-intercepts, when I graph that line, I see that those 2 lines are parallel, which means they're never going to intersect, which means we have no solution. The ones with one solution we've already seen in this before in this PowerPoint. And if I graph something like this, when you turn y equals negative y minus 3, sorry, let me go ahead and show you this graph. So when we have y equal y minus 3 is equal to a 2x minus 2, we're going to have to turn that into slope-intercept form by adding 3 to both sides. Well, once I add 3 to both sides, I have y is equal to a 2x minus or plus 1, which is just equivalent to that first equation that they've already given us, that y equals 2x plus 1 right here. Which means we're really graphing the same line, which means our answer would be infinite number of solutions. So a system of equations consists of 2 lines. One line passes through 2 and 3, and the other 0, 5. And the other line passes through 1, 1, and 0, negative 1. Determine if the system has no solution, one solution, or an infinite number of solutions. So The first thing you're going to need to do is find the slope of these two lines. So we find the slope of the lines by doing y2 minus y1 over x2 minus x1. So for this first equation right here, it's going to be that 5 minus 3, and then 0 minus 2. We get negative 2 over negative 2, which equals negative 1. That second line, we're going to have to do negative 1 minus 1 and 0 minus 1. So we get negative 1 over negative, we get negative 2 over negative 1, which gives us a positive 2. So then we find, since we found our slope, now to put them both into slope-intercept form, I need to find their y-intercept. The nice thing for here is they've given it to us in their points, 0, 5, and 0, negative 1. So then we can graph these two lines. The first one I know has a slope of negative 1 and a y-intercept of 5. So that's going to be negative 1x plus 5. And that second one has a slope of 2 and a y-intercept of negative 1. So it's going to be y equals 2x minus 1. So since I have these two equations, they have two different y-intercepts and they have two different slopes, then they're going to intercept at one solution. So one solution is our answer here because they're going to intersect exactly at one point. If they had the same slope but different y-intercepts, it would be no solution. If I got both of these into slope-intercept form and they were the same line, then there would be infinite number of solutions. And when I graph those two lines, I do see that they intersect at the point 2, 3. So your assignment is on Schoology, and hopefully it is printed out for you as well. If you have any questions, please send me an email. Hopefully you're able to watch this. I hope you have a wonderful day. I will be back as soon as I'm feeling better. I'll see you all later. Bye.